So next up is another one that I was excited about is the wind turbine with 75% efficiency. Again, we look for new, novel, and obscure, and this is definitely novel and obscure. I'm going to go ahead and turn this over to Joe and Todd. I think Joe's going to be talking. Are you going to be running the slides too, Joe?
Yeah, I'm going to try it.
Okay.
So
there it is.
Oh, hold on. Now I got the same issue that the earlier presenter had. Hold on.
No, you look fine.
It looks okay?
Yeah. Yeah, you're on slide 2 right now, but
okay. Yeah. Hold on then. Okay. Thank you for inviting us here. And any questions, sure, go ahead and ask. So our scenario is innovative engineering. And when we started talking to, or as we've been talking to members of the military, the idea of increased grid resilience, hardened base security was certainly one of the real important things, and also anything to do with decreasing the cost. So from multiple persons within the DOW, we've heard the estimated cost of fuel is $400 per gallon in the field. So we wanted to try and address the reducing costs and also all the elements of having a microgrid, really what Mark was talking about, becoming offline from a grid that might be tens or hundreds of miles away. And our technology is unique because it's based on physics, and the ideation was performed by Porsche Engineering. They don't normally deal with startups, but they thought we had a very innovative idea, and so they pursued it. Our technology is scalable and it's modular, and we'll have some examples of that here in the next couple of slides. So, hold on, why is this not forwarding? Okay, so a number of applications, and one is on ships. And I did a zoom in on what the turbine might be like on the top of a ship. And Porsche made this graphic, and they said that having a couple of turbines on top of the ship would create more electricity than covering the entire ship with solar panels. The applications in the air, let's say cell phone towers, communication towers. They also looked at integrating these modules into buildings. And again, on the applications side, as I said before, the technology is scalable. So there's a version there, and there's some people on the left side of the picture, and sea, air, and land. I'm sure that'll ring some bells in naval circles, but as we look at our markets, it was farms too. And so this could be a size that would run a farm. And so it's typically the sizes we were looking at, the size of a silo, the size of a good sized tree. And then again, applications, disaster relief. So FEMA is one possibility. And then we've got a a version in there of a military application. But as we envision this, it is packing the materials in a container, and then once that container is dropped via helicopter or plane, and it's certainly not a container necessarily that size, but when you look at some of the command centers of FEMA, they're basically out of a little larger container. And also airfields, a natural spot to have turbines because they're wide open and there's plenty of space. And so that's an application that we looked at. We'd also been talking to a couple of drone manufacturers.
Joe, it's Eugene.
A question?
Yeah, this is Eugene. So go back to the previous slide if you can.
The airfield?
Yeah. So the height restrictions that they're going to have at the airfield, did you address those when you were looking at this?
No.
Okay.
We didn't. Do you know what that is? That per airfield, or is it a general height restriction, or?
It's going to be where the flight paths are.
Sure.
It's going to be depending on the volume of traffic. But if it's something that you're really interested in investigating, I mean, I can put you in touch with the FAA.
Yeah, sure. That would be fantastic.
Okay.
Yeah, Joe, I was sorry, Mark from Fiverr here. Firstly, congratulations. I don't want to hijack the presentation. You're doing a great job. Thinking out loud, obviously space is premium. You're generating electricity. If you're not already on the roadmap, teeing up with satellite, teeing up with Spacecom, you're generating the power. You can also take the connectivity as well as the power, and you'll be killing two birds with one stone. So I think that if you're not already talking to telecoms, shout. But I think that would be a slam dunk. You know, if you can get power and connectivity, certainly with some of your scenarios thus far, you're winning.
Yeah, connectivity. That's a great point, and we have discussed that. But I didn't include those in a slide, so I will address that. I think that's a great idea. Todd, you're taking notes, no doubt.
Sorry, mate, my bad. I just live in a world where connectivity is premium, and you know, we're now turning to satellite more than cellular, and it's easier to get. So from your point of view, you can kill two birds with one stone.
I appreciate that. Thank you. I was talking about the drones, and they saw the possibility of reducing, because I'll get to the technology a little more here in a couple of slides, but it's reducing drag is a big part of what we're doing, drag behind the blades, the rotors. And so when a couple of the people that we talked to in Northern California, they were thinking that this might increase their range by 20% if we could reduce drag. So, but we haven't thoroughly vetted that as we have in a bunch of the other scenarios here. Some of the other applications that we were looking at were, when Northrop Grumman looked at this, they were talking about potentially putting them in the leading edge of aircraft wings. And so that's what they discussed. And then also our technical principle really deals with, again, drag and smoothing airflow, and water has more of a drag than air, and so the potential of putting this in running water would certainly help too, and maybe have even a bigger impact, but we have not done the physical testing in water, but we certainly have in the air. And so as we were looking at our major customer segments, the military was one, tribal nations in the U.S. was another, and then also agricultural applications, because go ahead.
This is Eugene again. So any kind of off-grid, I mean.
Correct.
You look at Puerto Rico.
Yes, islands, absolutely. And all the problems that Puerto Rico's having with their grid, which is basically continually being destroyed, really. And island nations you have the trade winds blowing constantly. And so that makes a lot of sense, because all of those places are making their electricity, no, not all of them, because there is some renewable energy, but no one wants to ship in diesel fuel. And also the market volatility and accessibility with what's going on in Iran has certainly made that very evident, the disruptions in supply. What we've got right now is we've got a signed CRADA with NPS, the Naval Postgraduate School. We've got a signed letter of interest from the Oglala Sioux tribe, and the Oglala Sioux is one of the largest physical reservations in the United States, and it's South Dakota, so it's very windy there. And in fact, all of the Great Plains in America are very windy, and that's where I'm based in Iowa. And the Midwest, that portion that comes down from Canada, gets very windy. And so just talking about some of the benefits, it's got a lowered acoustic and visual signature. You can see a typical large-scale wind turbine from miles away, so that's a big visual signature. The problem with the large wind turbines, though, is it's just so complicated, and the equipment that's necessary to erect the turbines requires specialized equipment, and it's very costly, and it's impractical in most places. And then we've got significantly increased power outputs from what we're doing.
Okay. I got a question for you. This is Eugene again.
Sure.
So I spent a lot of time at, so Navy has a facility off the coast of California, San Clemente Island.
San Clemente, sure.
Well, they have a couple of wind turbines there that are, the big bulky ones.
Right.
But they don't work because it's constant wind. It's just like San Diego. It's wet and damp, but the problem is it's salt air.
Right.
And so it just tears everything up. And then they've got on the barracks, they've probably got 4 dozen of these smaller turbines that, none of them work because they're rusted.
Right. And so that's another advantage of our design, because a lot of it can be shielded. But when we talked to Portia about all these scenarios, trying to get rid of some of the drawbacks from the traditional wind turbine design, whether it's shadow flicker or harming birds and bats, all that kind of stuff. But we thought of cold weather turbines. We thought of coastal turbines. And if the generator itself is protected, then it's going to be less susceptible to the elements. And then as we've got a couple of containers listed or shown in this slide, standardized containers that can be shipped. This is the ISU 910, I believe, pushed out of a helicopter, dropped out of a plane, trucked into somewhere, and that all the elements would be included in the container. And then the design has evolved continually, but where we're at now is 3D printing of the internal structures and then a fabric type housing instead of a solid housing. We also have the option of ballistic fabrics to make it resistant to small arms, fire, or shrapnel. And then the ask, $350,000, we need to complete the CRADA. And then we've been talking to CENTCOM, and they were talking about bypassing some of the prototype stage and just putting it directly in the field. So those are the options there. We've got a QR code here to go to our LinkedIn page. Here are our key personnel, Todd and myself. Here's our contact info, and we can put that certainly into the chat. And then my next slide here is questions. I've got some backup slides. Eugene and I and Todd were talking the other day, and so I can go into more of the technical details if you'd like to see them, but any questions right now?
A couple.
Sure.
So, from what you've designed, how far into the ground do they have to go to stay stable? Bear in mind they're catching wind and then converting wind to power.
Yes.
Do they have to go quite far down? And I'm guessing the modular units are pretty damn heavy in reality. Otherwise, they're going to move around quite a bit, right?
Well, sure. You're going to have yaw problems, but it all depends on. We've reduced the weight considerably from where we were starting, but that we've got a number of what we want to call innovative solutions to try and mount these into the ground, if that's the right word. Install them into the ground. They can go on buildings, certainly. They can go on containers. If there's a battery backup solution, then a lot of the things can be put into the containers to add more weight. But we're looking at because obviously where you mount it and how you mount it is going to be a big deal. So we're looking at a number of alternatives to the typical having a big concrete base, because trying to make concrete and doing it for hundreds of miles from the nearest outpost or something. So we are looking at those options, but we don't have exactly the answers yet.
No worries. And also, just to be greedy, are the units smart? Do they feed analytics back? So is there some visibility on the outside perimeter of every asset? So if I was, when we talk about 5 volt and when we talk about what we're doing from a perimeter protection point of view, have you guys explored what the risk of hijacking the actual standalone units are for misuse or manipulation at all?
No, not really. That's an excellent point. We've got a Navy SEAL who's on part of our team, And the one thing that he was talking about was one round can render a solar panel inoperative. And so where he was talking about the same type of thing where a solar panel could be hijacked or stolen, it would be a little more difficult to make off with one of these. But your comment about connectivity and no reason why there couldn't be a camera on here to monitor movements or monitor theft or anything else. So that's
just mindful that the world's getting more connected, and you may find yourself in a position where customers might want to see their assets, know they're online, know they're working, and obviously from a support point of view, you might want visibility.
Right.
We're having a lot of off-record conversations in the same military sense for things like submarines and aircraft and how you kind of airlock bad actors out. So if you look at our disconnect to protect premise, it's about making sure that it's not accessible or visible in the first place. Because if you're protecting OT or critical infrastructure through what you're powering, the last thing you want is for that power supply to fall off because someone has jammed it or hijacked it or manipulated. So just an OT CNI cyber point of view, I think it's incredibly powerful, but you want to also not trust anything. So zero trust is not enough. It's zero chance in Purdue and CNI. And that way, if you go onto a ship, you can't be hijacked. So, it's a different premise. But love what you guys are doing. Thanks for sharing so far. I'll behave myself.
We could have Firebolt within there, so we could go online offline as necessary.
Yeah. I'm already halfway there, right? But no, as a techie, I'm going to behave myself and let you carry on doing your job.
Can I have a question now, please?
Sure. No, I love it, Mark. I love the comments.
No, he's a good guy, I believe. So in terms of your market, I'm quite intrigued. Obviously, you're in the US and you're looking at a lot of US opportunities. How many are you patented, your technology? Are you able to take it into other territories?
Yes, patented.
Eventually, I'm not quite sure where you are on your business growth and strategy, blah, blah, blah. But assuming that like most entrepreneurs, you want a bit of world domination in there sometimes. Are you looking, because places, the fact that you are talking about out of reach places or normally served places, I don't understand the engineering. I'm not that clued up. But I could imagine a number of African nations, for example, where natural resources is the primary route to doing what they're, to get their resources in place. So I was just intrigued how it's scalable because it's just numbers, but how practical it is in terms of the implementation, the planning, the generators, the infrastructure needed to actually operate the turbine and get the benefit of it. Is it complicated?
No, it's not very complicated. And one of the ideas that I want to say it's kind of innovative engineering. So when we started with this, we were looking at having generators built to our specification, and they were very costly. And then we came up with the idea of just using modified car alternators to serve as the generators. So getting the economies of scale of an alternator they're making 300,000 of them. And we're trying to use as many off-the-shelf components as possible. And so really taking what exists now and applying it to the turbine to simplify it. And yes, we would love to have these all around the world for sure. But at the beginning, we're kind of copying the Sequoia Capital model, which is go to the markets where they need a product that works first. And so we looked at residential in the US, but it's just a little too complicated trying to build a distribution network across the entire country. We want to go to customers that would be interested in buying multiple units at the outset. And when I say multiple units, I mean anywhere from hundreds to thousands of units to try and figure that out. So,
right, so let me give you another little nugget then.
Sure.
I would look at cell towers.
Yeah.
Where I did a piece of work once for Vodafone, and one of the biggest challenges they have is people steal generators, they steal the batteries. If you can have a turbine sensibly sized somewhere near a cell tower, there's something like there's thousands of cell towers cell towers around the world, and the networks, going back to Mark's piece about connectivity, the cell towers require power, and they need it remotely because some of them are in the most obscene places in the world.
Mm-hmm.
So
cell towers were certainly one of the main initial places that we looked. Todd, did you have a question or a comment?
Yeah, I'd say I would expand on that too. Being here in California, we lost 1 million acres in the Northern California fires. Yeah. And one of the biggest things that happened is the communication towers went down because they didn't have any power. Now, communications is vital to people surviving and not getting killed, knowing where to go, when to go. And the word that I've been getting from the state of California is, this would be a great solution for their emergency communications, right? So it just ties into exactly what you're saying. You're right, because they can't get out to fill the diesel generator that's powering the tower, right? Because that's what they do today. There's an actual diesel generator.
But if you take a number of the outreach places where some of these cell towers are, they actually, they are on dirty diesel, and the diesel gets stolen, the generator gets stolen. If that's my logic and my premise. Again, it's like it's a bit like our solution. Everybody needs it. It's just who, when, and how.
Right.
Yeah.
But anyway, there's a particular South African company in that particular market that I will try and introduce you to. But Vodafone bought them because they like them so much, but didn't know how to use them.
Fantastic. Mark, you had a question? Thank you, David, for those comments.
Mark, you're muted.
Mark.
How amazing. Everyone, enjoy the piece. Data centers. I would just put the strategy that is coming down the hill for the data centers. There is not the energy throughput to deal with the capacity on a global basis, a global problem. I think that, this is really an important area. So your critical communications point, couldn't agree more. What you do have is on the communications part, Joe, is not just cellular. It's also about, for you boys in the US, P25. In Europe, it's about Tetra. It's about having business radio and critical communications. So going off cellular, especially with some of the conversations you're having. And I would suggest that there are already modular forms that will fit in what you've got. I've seen some weird and wacky things that would fit quite cleanly on what you've already got. So you may wish to look at, the likes of Microgrid solutions, and, these guys are always looking for innovative ways of how to, operate or unlock new revenue streams. And you're a power source. And it's one of the most attacked vectors in the world when it comes to warfare. And So if
Yeah,
people
the
can't get to it
microgrid.
physically, they'll get it to it across the ether or the IP. And that's where we're different, right? So 5-volt is non-IP versus IP, and that's why we're a bit of a special one.
Let's see. There was a question.
Yeah, Jeremy. Yeah, so I was gonna ask you to do this for the next presentation. If you could do a cost comparison
Sure.
of what your turbine costs. The other thing I'd like to see is the cost to replace blades or a turbine, or just put yours on top of an existing tower, or existing pole in place of the turbine. Another thing you may want to do is talk about wind at different heights.
Yes.
Yeah, but I think that, and if you look at the installation cost, the logistics of getting 100-foot blade from point A to point B is a nightmare. I mean, I've passed these things on the highway,
yes.
and they shut down roads to get these things through. So that cost has got to be exorbitant.
It is exorbitant, and the cranes to mount those rotors on those giant utility scale turbines, $100,000 a day to rent them. And there's, yes, I mean, I think it's undeniable that the wind velocity is higher the higher the elevation goes, because there's issues with drag across the surface of the earth and all those kind of things. And so the laminar airflow is smoother the higher that you get. But the problem is the inertia of getting those big blades going, and most of them are powered to start them spinning, but the amount of energy it takes to spin a blade that weighs 10,000 pounds versus a carbon fiber blade that weighs a pound or half a kilo is significantly lower. And then there's all kinds of airflow between things, between buildings, between hills, between trees. I mean, our turbine was designed to try and pick up a lot of that potential kinetic energy in the wind that certainly a large scale turbine could never hope to address.
Yeah, and those large scale turbines have an operating window that they can't operate above a certain wind speed.
Exactly.
And yes. Do you have those restrictions as well? And I mean, and if you do, I'm sure you can operate at a much higher wind speed, because I know in California, I've got family in Sacramento area and San Francisco, and there's turbines there, and when those Santa Ana winds start going, they're not producing electricity because the winds are just 70 miles an hour is just too strong. Right. So they're locked down.
It is, yes. And that's due to a number of factors. One might be that the generator just overheats and it's not designed to withstand that. There's also, I mean, that's the primary issue. But with a smaller generator, there are things you can do to cool it. And so that's one of the issues. And one of the reasons I think that our turbine has the potential to really take advantage of those higher wind speeds, because that's when you're making all the power. And so battery backup, of course, would be great, because you want to try and capture all that energy and store it if you can. But I'm really excited about the possibility of figuring it out how to how to capture the energy at the higher wind speeds, because the power of the wind is a cube function. So you double the wind speed, you make 8 times the power. And so a lot of people are talking about, oh, it cuts in at low wind speeds or whatever. Okay, fine, but you're not going to make much electricity from a wind turbine when the wind's blowing 2 meters per second or 5 miles an hour. So that's not really the sweet spot of making energy. It sounds good, but the reality is you're not going to be making that much energy then no matter what. And so, yes, you can optimize the turbine with the blade shape and a couple of other things to pick up the power at low wind speeds, but I don't think that's where the real money is. So,
is there a possibility to install gears?
Yes, absolutely. Yes.
Yeah, to where the lower wind speeds you can, you're gearing it down, I guess, so that you're generating more power.
Yes, you can, more torque, because the function for how much power you make out of a turbine is the exact same formula as a horsepower, or as a engine makes, a motor makes power, which is torque times RPMs. So if you can increase the torque or you can increase the RPMs, either way makes more power. Do you guys want to see anything about the technology? I've got these backup slides. Should I show those?
I think we only got one person left. That's
okay.
Tank.
All right.
Save it for next time.
Okay, sounds good.
Yeah, but if you could pull the stuff that Jeremy wrote in the chat out, sure. I think that those would be good points to make on the 27th. And I do apologize for this. This is this is a major anomaly here today. I don't know what happened.
And there I was feeling totally guilty.
So
well, yeah, I mean, we've heard a lot of times, oh, we've never seen that before. So let's just say it is an anomaly and hope for better things on the 27th. Is that the day you said, Eugene?
Yeah.
Yeah. Great.
Yeah, and I'll send that invite out.
Fantastic. Well,
a lot sooner. I'll probably send that out next week.
All right. So I guess that's it then.
That is it.
Thank you, Eugene, again. Do appreciate the opportunity.
Yeah, and I do apologize. You can go on YouTube. You could go on YouTube and look at the videos and probably see some of the attendance. But it's been.
Yeah, I was going to say
it's a good dry run.
Yeah,
there's 30 odd names on the invite on LinkedIn that we can subtly say, hey, we missed you guys. So.
Yeah, I had, like I said, I had almost 100 people accept the email invitation. I had like 60 on the LinkedIn invitation, and all of that was normal. This is just amazing.
Well, like I said, we've heard many times, oh, we've never seen that before. So it's just a minor bump in the entrepreneurial road.
I agree.
It's been fun.
And I actually, right when the Iraq War happened, I was at a trade show in Williamsburg, Virginia, actually. And nobody showed up because it was literally that night or the day before, because this was a government trade show kind of thing. that night or the day before is when we went to war, and no one showed up to this trade show. I mean, all the exhibitors, I mean, one of them had footballs that they were giving away, the little foam footballs, and we're playing football inside. I literally, they only did it for one day. It was supposed to be 3 days, and the hotel shut it down.
I'll give you another one. I was at something, there's a fintech exhibition globally every year. And in 2008, it started the day after Lehman Brothers collapsed. People, the senior execs didn't even get off the aeroplanes. They just said to the pilot, turn around and fly us back. It was very similar to that, Eugene. The whole exhibition was people spent thousands of dollars on stands and people being there, and it just didn't happen.
Yeah.
So I totally get you. You can't plan for those things with all. No. It's just shit happens. Sorry.
Yeah, no, but I'm definitely gonna see what if there is anything, if there was a sunspots that were impacting internet or whatever.
It definitely wasn't me. I didn't touch it.
You weren't featured.
I have the capability, but this time I behaved well, and just probably surprised David because I stayed quiet for a long time. I was doing good.
All right, Eugene, thank you very much.
Yep, thank you.